Hello everyone, I want to just showcase my build that I've done here really quickly. By the way, sorry if I sound a bit off, I am really sick, but I do want to do this anyway. And that is a 8-bit comparer. What it does is it takes two inputs, two 8-bit inputs, and it tells you which of the two is greater. So for example, if I do, let's say, a 5 and an 8, it'll tell me the 8's bigger. This obviously works with anything really, and then tells you that's bigger, and then we'll turn this off, and let's add another one of these, and then you can see there, it tells you that that side's bigger. So now obviously there's two versions for this. One which is the void version. This is probably something if you don't really care about the output. Well, in this case, what void means is that the input numbers get voided. So if you don't do anything else with the output beforehand, you lose them, and you just know which input is greater. This can be helpful, like for example, in my multiplier over here, I've used this. But instead of using the output from it, I already use it somewhere else. So this is something you'll probably want to do. And now there's the second version, which it preserves the output. So if I, for example, do something like this, it preserves the output. This is a tiny bit slower, not much, and quite a bit bigger. But this also has its benefits because it's got everything inbuilt. So if you just needed, don't have the space for using the inputs, running it along, then this is probably the version you want to do. Some extra notes. If you do want to extend this, I will tell you that it is quite difficult, as this works with signal strength at the back here. So if I do this, you can see that it's at 1. So it is quite difficult to extend it. You can do something like this here for every single step if you want to go up to 16-bit. However, it's not that great, and the thing I did here is not stackable, so you'd have to come up with a different solution. Alright, so how it works is that it takes here in the middle, it checks which bits are differing, so these would cancel out. You can see here this one's off, but this one is on, this one's on because it's on this side, and then this one's on because it's on this side. And then it just runs it into a slab tower, where at the top, they cancel out. Because you can just check which one is the topmost, and this is important because you can't just do it without first excluding all the ones that are the same. Because if you did, then, this would indicate that they're the same signal, the exact same signal. So you first have to get rid of this and just check down of which one is, different, the utmost different. Now, the good thing about this is that you can also check if they are the same signal. So if you do want to extend this, this would, give the same output as not having any input. But if you know you've put an input into here, by either checking manually by using your input, or by, just checking, like adding another slab tower onto this and making a third thingy here, you can check whether they're the same or not. I hope this is useful to some. I will leave schematics of these two in the description, and I hope you have a lovely day.